Hi everyone, so today we're going to be looking at malfunctions in homeostatic mechanisms. So we've looked at a few different homeostatic mechanisms in terms of how our bodies regulate temperature, water levels, and blood glucose levels. And so we're going to look at malfunctions in this process. In particular, we're going to look at how type 1 diabetes, hypoglycemia, which we've kind of looked at already, and hyperthyroidism are malfunctions in homeostasis. All right, just a recap from last lesson. So this is the stimulus response model for blood glucose levels and how when there is a change outside of our normal blood glucose levels, the pancreas, or specifically the islets of Langerhans tissue, detects this. The islets of Langerhans are also the modulator, and then the effector can be a variety of types of cells and tissues, which can then increase or decrease blood glucose back to the normal level. So when there is a malfunction in that process, people can have type 1 diabetes. So let's look at diabetes in general. There are two different types. Type 1 is the type that you were born with, so it's an autoimmune disease. Type 2 diabetes can be developed later in life. So let's look at type 1 diabetes. This is the malfunction in homeostasis that we're going to focus on. So in type 1 diabetes, we have it is an autoimmune disease. And so this is when our beta cells in the pancreas are targeted by our immune system. So our immune system is essentially mounting a response and destroying the beta cells. And so we know that our beta cells release insulin. And so if our beta cells are destroyed, they cannot produce insulin. This means that glucose stays in the bloodstream instead of being taken into the cells for cellular respiration or being taken into being stored in the liver as glycogen. So homeostasis is not maintained. Those high blood glucose levels stay high. Here we have a graph that describes this. So in a healthy person, if you're eating at 0.0 over here, your blood glucose levels are going to increase, and then your pancreas is going, or your beta cells are going to release insulin, bringing back your blood glucose levels down to the normal range. In a person with type 1 diabetes, once they eat, their blood glucose levels are just going to increase. And they're going to stay really high because insulin is not being produced because the beta cells are damaged, and therefore the glucose is not being removed from the bloodstream. So what are some of the symptoms of type 1 diabetes? Well, we've looked at this already. So we've looked at hypoglycemia, and hypoglycemia is high levels of glucose in the blood. And this is what happens in type 1 diabetes. So some of the symptoms can be increased urination and excessive thirst. This is because that high glucose levels in the blood, so that high amount of glucose is being pushed through the glomerulus into the nephron. And this then disrupts our ability to reabsorb water through the nephron back into the bloodstream. So think back to the structure of the nephron and how glucose can be pushed through the glomerulus into the nephron. We can also have excessive hunger and lethargy. This is because our cells are not receiving the input for cellular respiration. So they're not receiving that glucose that's in the blood. It's staying in the blood rather than being taken up by the cells. This is because it's the hormone insulin that produces that response of the uptake of glucose by cells. So if we don't have insulin, those cells aren't going to take in that glucose. It's going to stay in the bloodstream. And therefore the cells are not going to have that input for cellular respiration, which means less ATP or energy is produced. So you're going to be more hungry and you're going to feel tired. You can also have weight loss. Right? This is because your cells are not producing energy. So it's going to start using a fat as energy instead, which is not good. Kidney damage can also be a long-term effect of hypoglycemia. So if we think back to this point up here, so your kidneys are filtering your blood, and if there's high levels of glucose in your blood and that's getting pushed through the glomerulus into the nephron, it's going to damage the nephrons, and therefore you're going to end up with kidney damage if this goes untreated for a very long time. We can test for type 1 diabetes in two different ways. So we can use a urinalysis. So this is an analysis of your urine. If there's excess glucose in the blood, it will be pushed through the glomerulus like we looked at in the last slide and excreted in the urine. So think back to the excretory system. If we find glucose in the urine, it can indicate diabetes. So we usually will dip one of these sticks into a urine sample and compare it to this scale. And it will tell us up the top the level of glucose that's in urine. So for a healthy person, you're not going to have any glucose in your urine. Blood tests can also be used to detect high levels of glucose in the blood and a failure to maintain homeostasis. So we just take it, we test your blood and we can test the amount of glucose that's in the blood. So what are some of the treatments for type 1 diabetes? Well, we have insulin replacement therapy. So this is replacing the insulin that your body is not producing. This starts with someone monitoring their blood glucose levels. It might be through one of these blood glucose monitors where you take a sample of your blood, there's a little pinprick on your finger, put it on that little strip of paper, and it will measure the levels of blood glucose, or measure the levels of glucose in your blood. Then you would take an insulin injection to bring back your blood to a normal level. However, this needs to be timed really specifically and really correctly, because if you provide insulin or you take an insulin injection at the wrong time, it can bring your blood glucose levels below normal, and this is another issue. So this is just a graph that shows how someone might time their insulin injection. So if you're eating breakfast here, you can see that this dotted light blue line is the glucose levels. So after breakfast, glucose levels in the blood increase. A person with type 1 diabetes might time their insulin injection with taking breakfast. In this darker green or bluey green line shows insulin action. So as glucose levels increase, the insulin is acting on the glucose. It is then taken up by cells or converted into glycogen, and the glucose levels decrease. And again, you would do the same thing at lunch and then at dinner. So now let's have another look at hypoglycemia, which is a malfunction in homeostasis. So hypoglycemia, as we know, is when blood glucose levels fall below normal. There are many causes of this. It can just be simply from not eating enough, too much exercise, or taking too much insulin if you have diabetes, or not eating enough after taking insulin if you also have diabetes. We know that glucose is essential for cell function, for cellular respiration, and if hypoglycemia goes untreated for long periods of time, this can lead to losing consciousness or even death in very extreme cases. So what are some of the symptoms of hypoglycemia? We have dizziness, confusion, shaking, difficulty concentrating, headaches, vision difficulties, and mood swings. Just think about how you feel when you haven't eaten in a very long time. When you haven't eaten, obviously your blood glucose levels are going to be low. You might feel irritable, which is mood swings. You might have a headache. You might be a little bit dizzy. You might have difficulty concentrating. I know a lot of you will have experience feeling the symptoms of hypoglycemia, especially during times of fasting, because you're not eating during the day. You might be feeling a lot of these things because your blood glucose levels are low. So what are some treatments for hypoglycemia? It's pretty simple. Eating. Eating sugar-rich food will increase the blood glucose levels pretty quickly, or in extreme cases, you can have injections of glucagon. So glucagon is the hormone that is used to convert glycogen back into glucose, which then re-enters the bloodstream. So someone, for example, who has diabetes and goes into hypoglycemia, they'll recognize this through a test. They might eat something quite sugary and then test again to see if their blood glucose levels have gone back up to normal. And this is just a simple summary of all of that I found very useful, that you might find useful too. And now we have our last malfunction that I want you to know about, and this is hyperthyroidism. So hyper meaning high, we know that. And then thyroid So we know this relates to the thyroid, which is one of the glands that we looked at in the endocrine system. So there are high activity levels of the thyroid. So hypothyroidism is caused by an overactive thyroid gland, which will secrete too many hormones into the blood. So this is your thyroid over here. It's one of the glands we looked at when we looked at the endocrine system. There are two hormones that this thyroid gland produces that I want you to know about. So firstly is T3, or triiodothyronine. I can't quite say it. I don't expect you to know this name. You can just know T3. The other one is T4, or thyroxine. So T3 and T4 are the names I want you to remember. So T3 and T4 have a very important role in our bodies. They regulate body weight, they regulate energy levels, temperature, skin, hair, and nail growth. They regulate your metabolism, and they're overall an important part of the endocrine system. So when there are high levels of T3 and T4, it is going to inhibit or stop the release of another hormone called thyroid stimulating hormone, so TSH. And this hormone is released from the pituitary gland, which is in your brain. It will also, so T3 and T4 in high levels, will also inhibit the release of thyrotropin releasing hormone, so TRP, from the hypothalamus, which is also in your brain. So T3 and T4 inhibit the release of TSH from the pituitary gland and TRP from the hypothalamus. In diseases that cause hypothyroidism, so an overactive thyroid gland, this inhibition, so that negative feedback of TSH and TRP does not occur. And therefore T3 and T4 continue to be produced. And homeostasis of those hormone levels are not maintained. So let's summarize this again. We have our thyroid gland. It produces T3 and T4. T3 and T4 then act on the hypothalamus, preventing TRH from being produced. So it'll stop TRH being produced. It will also act on the pituitary gland and stop TSH from being produced. Those two hormones usually act on the thyroid gland and help it produce T3 and T4. So this is a negative feedback loop because the T3 and T4 are stopping TRH and TSH from being produced. So it's counteracting that stimulus. Here's another diagram to help illustrate this. So we have our hypothalamus that produces TRH, acts on the pituitary gland, which produces TSH, which then acts on the thyroid gland, which produces T3 and T4. And then T3 and T4 do their thing. T3 and T4 in high levels will inhibit the hypothalamus and the pituitary gland, preventing these two hormones from being released and therefore preventing T3 and T4 being released. So this is when there are high levels of T3 and T4. If there aren't high levels of T3 and T4, this inhibition won't happen and T3 and T4 will be produced as normal. So let's look at some symptoms of hypothyroidism. So we're going to look at specifically Graves' disease, which is an autoimmune disease, and it's a common cause of hypothyroidism. So essentially the immune system keeps stimulating the production of T3 and T4, so from the thyroid gland. So the thyroid gland is going to be very overreactive, and this can cause a lot of things like anxiety, tremors, goiter, which is like an enlarged growth of the thyroid, bulging eyes, fatigue, thick red skin, and rapid or irregular heartbeat. So this is a goiter. So this is what an enlarged thyroid looks like, and then Graves' disease can also produce this bulging and redness of the eyes. Some treatments for hypothyroidism are anti-thyroid drugs to inhibit the release of T3 and T4. Also taking radioactive iodine, because radioactive iodine will destroy the thyroid cells and therefore less T3 and T4 will be produced. And this radioactive iodine doesn't affect any other cells, so it is safe to use. We can also surgically remove the thyroid gland. However, if we surgically remove the thyroid gland, we then have to take hormone replacing drugs for the rest of our lives. So these are just a few of the ways we can treat hypothyroidism, which is the overactivity of the thyroid gland, producing too much T3 and T4. As usual, please bring your questions to class, and I will see you there.